One extremely useful xShape modeling technique is to insert sketches or pictures into the physical product and use them to shape the outer edges of a primitive subdivision surface. These pictures can be inserted into planes, scaled, oriented, and placed within or behind the model. In this example, we will start with a primitive sub-D box and using pictures of the top and the side, create a bike seat. In addition to inserting pictures, we'll also take a closer look at the Design Manager tree in order to reorder features and make use of rollback. We'll also delete loops, align mesh points, and scale using the non-uniform option. The model is symmetric, so we will take advantage of that using the Symmetry tool later in the design process. In order to do this, let's do some setup and add a point at the origin position. This will make it easier to place and center any primitive sub-D surface that we will add. Click the Features action bar and point. Click OK to add the point at the default 0, 0, 0 position. We'll set up a picture on a standard plane. I'll add the first picture. To do this, I'll click the Tools action bar and Insert Picture. Next, I'll click Choose File and select the image file seat plan and click Open. Next, select the XY plane as the picture plane. This is the symmetrical shape. I'll use the default size and settings and click OK. Note that the transparency slider can be used to make the picture partially transparent. In this case, we'll leave the picture at the default transparency setting, which is opaque. Now I'll click the Subdivision action bar and add a box to the point with the default settings. Note that we will use symmetry later in the process, and we'd like to match up the picture and the center of the primitive. Click OK. Keep in mind that the primitive and the picture can always be moved and adjusted later. I'll click Tools and Insert Picture again, and note that the primitive sub-D surface is no longer being edited. The dialog has been closed automatically. Using the same procedure, I'll select the second image file seat profile. Note that the plane can be selected from the Design Manager or graphically in the work area. We'll select the ZX plane. Click OK. The picture has been added as a feature, but note that it appears after the Subdivision Surface 1 and Knit Surface 1 features, last in the Design Manager tree. This was a mistake, as I really wanted the picture features to be together before the Subdivision Surface 1 feature, but I want to show you how to fix this common mistake. Why should the picture feature be higher in the tree? In order to use the picture as a shaping tool, the picture must precede or exist before the primitive subdivision surface. It doesn't, so we'll have to reorder it. To reorder, drag the Picture 2 feature to a position between the Picture 1 and Subdivision Surface 1 features and drop it. Note that reordering changes the sequence of the Design Manager tree and may change the model. I'll change to an isometric view. I need to edit this picture to work with the existing picture, so I'll double-click it and edit it. Next, I'll click the Scale option and use the Percentage option to size the picture to match the length of the existing picture. We'll need changes in small increments, so I'll click in the number box and roll the mouse wheel to increase or decrease the value. Using the robot, I'll drag the sketch upward to connect the two pictures at the front and click OK. The rollback bar is a vertical line on the left side of the tree with a handle at the bottom. The handle defines the current position of the bar, now at the Picture 2 feature. The newest features are placed after that position. The default position for the rollback bar is at the bottom of the tree, as the tree builds from top to bottom. all features below the bar are suppressed. Suppression effectively removes and hides that feature and any child features that depend upon it. By comparison, hide simply toggles off the visibility of a feature. It is useful when you'd like to place a new feature at a specific position in the tree. You can roll back to that position before adding the feature. In this case, I'll drag the rollback bar down to sit at the last feature in the tree, the Knit Surface 1 feature. Now let's edit the primitive sub-D box by clicking a face and clicking Edit Feature. To make the next step easier, let's make the primitive sub-D surface transparent. I'll click the Transparency option and drag the slider to the right. I'll select all of the box, scaling and positioning it to roughly cover the pictures. Note that it's okay to scale normal to the symmetry plane because it scales about the center. Avoid dragging the primitive in that direction and pulling it off center. In this case, symmetry is defined by the ZX plane. In some cases, less loops are easier to work with, and that is the case here. I'll click Delete Faces Loops and delete one loop in each of the directions. This leaves us with one loop on what will be the symmetry plane. Now we'll be shaping the primitive to match the picture as closely as possible. To do this, we'll use box selections to pick all the vertices through the model and push and pull techniques, moving large or small groups of vertices along arrow or in planar directions. Depending on the complexity of the picture, this can take some time, but remember, pushing or pulling vertices has an impact on the surrounding vertices, both those in the same loop and parallel loops. This is an iterative process, so you may move the same vertices more than once to get the desired result. Make use of undo when the push or pull gives unexpected results. And it's okay to move small groups of vertices. It may take longer, but it is more often accurate and predictable. Let's review the push and pull procedures while the video plays. First, select a group of vertices by box selection. The box ensures that all of the vertices through the model are selected. When the robot appears, use the arrow or planar areas of the robot to drag the vertices in the viewing plane directions, up, down, left, right, or on an angle, to reshape the geometry. As you might expect, there are quite a few pushes and pulls needed to get to the shape we want. Let's speed up the picks here to save some time. An alternative to box selection of vertices is to use the selection options to filter types such as vertices, edges, faces, edge rings, edge loops, and face loops. Any entities is the default setting. Although we tried to keep the primitive centered on the picture, it may be a little off-center, or the loop or loops may be off-center. If the primitive is off-center, I'll drag the whole thing to center it on the ZX plane. In this case, it's the loop, so we'll box select it and move it roughly to center it. Now we'll set up symmetry using the ZX plane before tracing the next picture. Moving vertices on one side move them on both sides, so we really only have to worry about matching one side. Using the same box select and drag techniques, shape the primitive to the picture. This sketch uses the same procedure, and it will also be sped up a bit. I'll toggle symmetry off and click OK. Note that the knit surface feature might have a warning after loops or faces are deleted. If this happens, just edit the knit surface 1 feature, add a face selection, and click OK. I can also hide the pictures. Let's take a closer look at the bottom of the model. It needs to be flat, but we can check. Let's click Tools and Section View. In the YZ section, it appears that the bottom is not as flat as we wanted. Close the tool. We'll use Align Mesh Points to fix that, starting with a change to a side view. I'll click Subdivision and Align Mesh Points. We'll use the plane to flatten the bottom. I'll click Align Mesh Points, and under Align Entity, I'll click Align Vertices to Entity. For the entities to align, box select the bottom row of vertices. They're on a curve, so it may take several groupings to do this. Box select the first set. Then press the Control key and box select the next set, repeating this procedure to select all sets of vertices. Under Geometry, click the XY plane and click OK. Looking at another section, the bottom has been flattened. The shape of the seat matches the pictures, but a design change has occurred. This change increases the width of the seat, but keeps the other dimensions of length and depth the same. Click Subdivision and Scale by Distance. And set up the handles across the width. This time we'll use the Scale Non-Uniform option and set the width to 50. Press Enter and OK.